Good morning, children. In today's class, we are going to learn some interesting concept called mathematical induction. What do you mean by this word induce? Induction, or I can say induce. What does that mean? This word induce, suppose you are watching a cinema. If it is very good, will you keep it to yourself? No. You will call your friend and inform that the cinema is very good. You also go and watch. So you induce her. Then that friend, will she keep it to herself? No. She will tell to 2 more, then 3 more. So the data pass on. From one person, it goes on and on. So inducing, we just motivate others to do that. What does mathematical induction mean? When I say mathematical induction, the first point, whatever is the given statement, consider it as P of n. Wherever n is coming, put 1, prove the result, that is LHS equal to RHS. For example, if you have this result, we have learnt in lower class, 1 plus 2 plus 3 and so on is n into n plus 1 by 2. How to prove it? So when I have this result, what is P of 1? Take only the first element, that is 1. What is P of 1 for the RHS? Wherever n is coming, put 1. Simplify the answer. So this tells me LHS equals to RHS. So P of 1 is true. The second step, assume P of k is true. What do you mean by the word assume? Don't ask why. So without reason, without proving it, we just take it for granted. So assume P of k is true tells you wherever n is coming, just put k. It's an easy step. Proving P of 1, taking the given question as P of n, all these are simple. But you can easily score marks, a 5-mark question. So the given statement, just name it P of n. Second step, wherever n is coming, I put 1 and prove the result. Third, wherever n is coming, blindly put k, that is assumption. Fourth step, this only is little difficult. Assuming this result, wherever k is coming, put k plus 1, show LHS equal to RHS. Once I do it, see, k is true, I assume, and I showed k plus 1 is true. What does this tell me? First step, I showed 1 is true. If 1 is true, 1 plus 1, 2 is true. If 2 is true, 2 plus 1, 3 is true. If 3 is true, 3 plus 1, 4 is true, and so on. So, the induction procedure tells me, if I show P of 1 is true, assume P of k is true, prove the result for P of k plus 1 is true, I can declare the given statement P of n is true for all natural numbers. Starting from 1, I can keep on telling 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, and so on. So we say n belongs to capital N, or in words, all natural numbers. Let us proceed with the exercise and have these ideas in mind and prove the result. Exercise 2.5, question number 1. Prove that 1 cube plus 2 cube and so on up to n cube equals n square into n plus 1 the whole square by 4. Copy the given question as it is as P of n. Put colon, not equal to. The statement, we have assumed the name P of n. To prove that P of 1 is true, LHS, P of 1 tells me only the first term, 1 cube. 1 into 1 into 1, that is 1. RHS, wherever n is coming, put 1. So 1 square, 1 plus 1 the whole square by 4. 1 square is 1, 1 plus 1 is 2, 2 square is 4 by 4, which is 1. So this tells me LHS equal to RHS, implies P of 1 is true. Having shown P of 1, the third step, assume P of K is true. What is P of K? Again, just copy the question. Wherever n is coming, put K. So 1 cube plus 2 cube plus 3 cube and so on up to K cube equals K square, K plus 1 the whole square by 4. N becomes K. That's it. The next step, to prove that P of K plus 1 is true. How to show that? LHS. Copy the given P of K as it is. 1 cube plus 2 cube plus 3 cube up to K cube plus. This is P of K. I want P of K plus 1. Put one more term. In the place of K, you put K plus 1. K, I am including one more term, K plus 1, the whole cube. But we know 1 cube to K cube. What is my answer from here? K square, K plus 1 the whole square by 4 plus this term K plus 1 the whole cube. In both the terms, which is common? K plus 1 the whole square is common. What is left out? K square by 4. This only I have taken out. K square by 4 will come. From K plus 1 the whole cube, power 2 is taken, so K plus 1 will remain. This is K plus 1 the whole square, LCM 4, K square plus 4K plus 4, cross multiplying. What is the next step? You just remember, this term reduces to K plus 1 the whole square into, this is 2 square, this is 2 into K into 2. So it is K plus 2 the whole square by 4. I have done LHS. Let me try out RHS. What is RHS? Wherever K is coming, put K plus 1. So this K square will become K plus 1 the whole square. K plus 1 will become K plus 1 the whole square. Wherever K is coming, put K plus 1. Divided by 4. Or it is K plus 1 the whole square into K plus 2 the whole square by 4. Check, both are same. So I am able to show LHS equal to RHS implies P of K plus 1 is true. As I am able to show the fourth step, the last line I will conclude the result, that P of n is true for all n belonging to capital N, or I will call this as for all natural numbers. Just recall the steps. Show P of 1 is true. Assume P of K is true. Prove that P of K plus 1 is true. Take and write P of n is true for all natural numbers. Question number 2. Prove that 1 into 2 plus 2 into 3 plus 3 into 4 plus n into n plus 1 and so on equals n into n plus 1 into n plus 2 by 3. The first step, let P of n equals, copy the given question, 1 into 2 plus 2 into 3 plus 3 into 4 up to n into n plus 1 equals n plus 1 n plus 2 by 3. The second step, to prove that P of 1 is true. So take LHS, that is the first term alone, 1 into 2. 1 into 2 is 2. RHS, wherever n is coming, put 1. So 1, n plus 1 I will write 1 plus 1, n plus 2, 1 plus 2 divided by 3. 1 into 2 into 3 by 3, 3 cancels, this is 2. So we will say LHS equals to RHS implies P of 1 is true. The next step, assume P of K is true. How to write P of K? P of K is 1 into 2 plus 2 into 3 plus 3 into 4 and so on up to k into k plus 1 equals, wherever n is coming, just put k. Now I want to show p of k plus 1. So copy this k as it is, write one more term. K becomes k plus 1, k becomes k plus 1 plus 1. Simplifying that, k plus 1 into k plus 2. This 1 into 2, 2 into 3, 3 into 4 up to k into k plus 1. From here I can write k plus 1, k plus 2 by 3. Now in the two terms, which is common, we can take out. K plus 1 is common. Also k plus 2 is common. What is left out? If I take k plus 1 and k plus 2, k by 3 is left out plus 1. Here nothing left out, so 1. How will I simplify this answer? K plus 1, k plus 2 into LCM 3, k plus 3. Now I will check whether it is the RHS. What do you mean by the RHS? Check here. Wherever k is coming, I must put k plus 1. So k is k plus 1. K plus 1 plus 1 will be k plus 2. K plus 1 plus 2 will be k plus 3 by 3. So exactly it is suitable. Anyway, we will work out the answer. So I want to show RHS wherever k is coming. Let me put k plus 1. K plus 1, k plus 1 plus 1, k plus 1 plus 2, whole thing by 3, or it is k plus 1, k plus 2, k plus 3 by 3. Just compare. This answer and this answer are equal. So we have shown LHS answer and RHS answer are equal. Take and write LHS equal to RHS implies P of k plus 1 is true. So we have completed all the steps. Take the question as P of n, prove P of 1, assume P of k, prove P of k plus 1. Therefore, P of n, the given question, is true for all n belonging to capital N, and that is the answer. Exercise 2.5, question number 3. Prove that 4 plus 8 plus 12 and so on up to 4n equals 2n into n plus 1. What is the first step? The given question, copy in the name P of n. 4 plus 8 plus 12 and so on up to 4n equals 2n into n plus 1. So we have just copied the question in the name P of n. To prove that P of 1 is true, LHS, write only the first term, 4. RHS, wherever n is coming, put 1. 2, n will become 1, n plus 1, 1 plus 1, or it is 4. So we see LHS equal to RHS implies P of 1 is true. As I am able to show P of 1, assume P of k is true. Copy the given question as it is. Wherever n is coming, put k. The next step, prove that P of k plus 1 is true. So copy from here 4 plus 8 plus 12 and so on up to 4k. Write one more term. So the same thing we have copied. One more term in the place of k, k plus 1 will come. 4 as it is, k alone will become k plus 1. 4 to 4k. From this step, I can write 2k into k plus 1 plus 4 into k plus 1. In these two, k plus 1 is common, also 2 is common. So I can take 2 into k plus 1. What is remaining? Here k plus 1 is taken, 1, 2 is taken. So I am left with 2. So my answer is 2 k plus 1 into k plus 2. What is RHS? Wherever n is coming or wherever k is coming, put k plus 1. So from this step, 2, k will become k plus 1, k plus 1 will become k plus 1 plus 1. Or I will simplify this answer as 2 into k plus 1 into k plus 2. From these two, we are able to show LHS equal to RHS. So, take and write LHS equal to RHS implies P of k plus 1 is true and therefore P of n is true for all natural numbers.